Welcome to another episode of the Clinical Data Informaticists series. Today we will be diving deep into the DICOM standard, still in the context of medical informatics.
I am Kinson Ho.
And I'm Peter Dobbs. We express no conflict of interest beyond our respective employment. All opinions and statements are our own. In this talk, we will learn about the DICOM specification and understand how DICOM facilitates interoperable imaging AI. We leave gaps in particular ML knowledge to be discussed in other CDI talks.
Hey, Peter, how have your projects been progressing since we last spoke? I remember you want to use your AI skill on medical imaging.
Hi, Kinson. It's been great so far. We were able to start applying AI on a few sample DICOM objects, though I still feel like I don't understand enough about DICOM. We showed a simple demo to our colleague on a sample CR study. She was really excited and wants to see more on different types of objects like MR, CT, pathology, visible light, all that stuff. So I think I need a more fundamental understanding of DICOM before we can continue. And on top of that, one thing we quickly identified during the prototyping is that we can generate some AI results, but that we have no way to share them. We'd like to communicate our results back to the PACS or VNA so that the radiologist can easily leverage it. Now, a custom integration with the PACS does not sound like a good idea because we'd like to avoid maintaining different integrations for different PACS. Maybe job security, but I'd rather develop new AI algorithms than have to deal with custom integrations.
That sounds like a good problem to have. I think I can help you here. Obviously, your algorithm will focus on specific object types to look for specific characteristics. Fundamentally, your AI model will need to understand any DICOM objects in general and produce some interoperable AI results such that this downstream system can understand.
I definitely agree. But when I did some Googling about DICOM, I found so much content. It's kind of overwhelming.
I understand. From my experience, you may find some information by Googling, but if you really want to do something with DICOM, one day you will need to understand the specification itself. So I'm going to teach you how to fish.
All right, let's get started.
You can find the DICOM standard at www.dicomstandard.org. It is free and open. There are three main parts of the standard: the current edition, supplements, which are major works that are currently being developed, as well as change proposals, which are smaller changes to the existing specification. DICOM is a broad standard. It covers both the data model as well as communication protocol. As a result, it is divided up into many parts. For the data model, Part 3 specifies the data model. Part 5 specifies the low-level data structure and encoding. Part 6 is the data dictionary, which is handy to look up a DICOM tag quickly. Additionally, for AI applications, Part 15 defines security and audit, which may be interesting. Part 16 defines coded values used for certain attributes. Last but not least, there are different parts that focus on communications, whether it is using the traditional DICOM binary protocol, the newer DICOM web using HTTP, or from media. The good news is that there are many open source or commercial DICOM toolkits that can really help you working with DICOM. I'm pretty sure you have already had some good experience in your previous prototyping.
Oh, totally. Now, I remember from our previous conversation that DICOM Web is the modern exchange protocol, but of course, we've had to support the DICOM binary protocol to communicate with the PACS. It's quite reasonable. The main challenge we're having is understanding the data model.
Fully understood. Let's dive right into the data model then. Metadata, also known as the DICOM header, communicate a rich set of attributes related to the object. An information object definition, or IOD, defines a data model for a real-world object. Since not everything defined in DICOM are applicable to all objects, a service object pair governs what are valid data elements for a particular object. It is identified as a subclass. One interesting aspect of DICOM is that persistent objects are composite objects, which means each object is fully self-contained. An implication is that if a study consists of thousands of objects, some attributes like patient identity or procedure information like accession number will be repeated across all objects. This means you can fully process each object independently without waiting for other information.
Ah, that's interesting. I did find an advanced imaging study that had thousands of separate object files for just that one study. So it wasn't easy to recognize the common tags just by scrolling through the study's metadata. So can you walk me through an example in understanding the IOD?
Absolutely. An IOD is broken down into modules that group related attributes together. It is helpful sometimes because common attributes like patient can simply be referenced in other parts of the specification without duplication. A module consists of one or more data elements or DICOM attributes identified by a tag. Each attribute has a type. Type 1 means mandatory and cannot be empty. Type 2 means mandatory but can be empty. Type 3 means optional. Also, sometimes you can see a C, like 1C or 2C. C means conditional. In the description, it will specify what are the conditions. Similar to many data models like XML or JSON, DICOM also support nested elements called sequences. In the specification, you will see the greater than sign indicating that the attribute is under a particular sequence.
Oh, okay. This is starting to make a lot more sense. When I looked at some data earlier, I noticed that each DICOM tag is a weird-looking identifier that looks pretty random. Can you tell me more about this?
I can see that you grow up in the age of XML and JSON, that each attribute is generally a human-readable string. DICOM Web supports this using the DICOM keyword defined in Part 6. Many DICOM toolkits also help you process DICOM objects without having you to memorize the DICOM tags. With this said, knowing a bit of the tag helps you understand DICOM. Each data element is specified by 4 things:
the tag, the value representation, which represents the data type in DICOM, the length, and the actual value.
A tag actually has 2 parts, a group and an element. Both group and element are hexadecimal values. Closely related attributes usually use the same group. All standard tags defined by DICOM use an even group value. DICOM also allows implementers to define their own tag to capture proprietary information on top of the standard. All private tags have odd group values. DICOM defines a specific algorithm how to generate these private tags without a central registry. To find out more information about private tags, you need to consult the vendor's DICOM conformance statement, which is a public document specifying the DICOM capabilities of the system.
Oh, nice. It's good to know that there's a rhyme and reason for how that metadata is organized. So I recall from our previous conversation that there are big concerns around PHI, which do exist in DICOM headers. Are there any best practices that I can follow to avoid ethical issues around personal health or other identifying information?
Indeed, whenever we deal with patient information, there are many regulations like HIPAA, GDPR that the system needs to comply with and handle PHI properly. In DICOM Part 15, it defines various attribute confidentiality profiles that handle different levels of confidentiality. Different systems have different levels of support for these profiles. Also, as an AI model provider, you will need to check with your PACS partner and the customer to see what responsibility each vendor has to take on.
That makes sense. I think I'm much more equipped now to handle the DICOM input side. But how about the output side? I've heard that if the AI results aren't able to be integrated to the PACS workstation, the radiologists aren't going to want to use it, and so our software will likely not be getting any traction.
That is very true. First of all, the AI model needs to capture and distribute the results. It may provide a way to display the results, or the results are captured in a standard format that other systems can display the results themselves. Ease of use for the radiologist is definitely desirable. Also, there are different types of results an AI model can produce, so it needs to capture each primitive precisely with well-defined semantics and encoding. Ideally, you can do all these things once and work with many integration as well.
Oh, agreed. That would really be ideal. And that's good to hear about. So far, from my experience and doing a little bit of research, I understand that there are several fundamental outputs or result primitives of an AI model. It can be qualitative findings, some quantitative finding, like a measurement, some location, segmentations, even a parametric map or a heat map. Also, you may want to track the same finding across images or even across studies as a time series. And last but not least, you definitely want to reference the particular images that show a particular finding.
That's excellent research.
Now, how does DICOM help in capturing these various primitives?
Absolutely. The fundamental structure in DICOM to support many of these primitives is DICOM Structure Report, or DICOM SR. The starting point is template ID 1500. It supports qualitative findings, measurements, locations, as well as contour-based region of interest. For more advanced results that you mentioned earlier, you can use DICOM segmentation object, which support pixel or voxel-based region, as well as surfaces, and DICOM parametric map, which supports saliency map. All SR segmentation objects, parametric map, as well as the general purpose key object selection object, let you specify a tracking ID as well as references to other DICOM objects. Recently, IHE Radiology domain publishes an integration profile called AI Results that gives you many more informations about each of these objects. Definitely worthwhile to check it out.
Oh, for sure. That's tons of great information. I will need to load up on coffee and start reading these.
That's perfect. Sounds like a plan. Here are some additional resources that you can check out.
Oh, awesome. Thank you.
Now, tell me, what have you learned today?
Oh gosh. All right, let's see. So DICOM is a broad standard documented in many different parts, which details what valid DICOM object means, as well as how to communicate the various DICOM objects. And DICOM has rich support for imaging AI on both the input and on the output of an AI model.
You've got it. AI support is also an active and evolving area in DICOM as well. So definitely check it out periodically to see what are new. Also, keep an eye on other courses in the CDI series as well as other SIIM resources.